Alright guys, today we're going to look at solving compound inequalities. One of the things that you need to be able to look at and understand about compound inequalities, those are any inequality that contain more than one inequality sign. As you can see, like on the first example I've got here, it has two less than signs, so this is a compound inequality. The first thing you want to do is identify that it is either an AND statement or an OR statement. Okay, all compound inequalities are one or the other, and that's very important in determining your solution. So it's either an AND statement or an OR statement. In this case, it's an AND statement, and the way I know that is AND statements are the only inequalities that are capable of being written in this particular form where they're all kind of pushed together. And so looking at compound inequalities here, the example I've got 3x plus 1 is less than 8, which is less than 7x plus 3. And so a lot of people will solve this in one inequality like it is. I personally like to split this into two simple inequalities with an AND that combines them. And so I'm going to do that at this time. I'm going to split this into 3x plus 1 is less than 8 and 8 is less than 7x plus 3. Now, you don't have to do this step if you're more comfortable. You'll see some people who will leave the inequality together and work on all three parts at the same time. I just prefer to do this. It helps me avoid mistakes. Okay, so I'm going to start with my simple inequality here on the left. The 3x plus 1 is less than 8. I'm going to subtract 1 from both sides of my inequality, which leaves me with 3x is less than 7, and then I'm going to divide by 3 to go ahead and finish solving for x in this case. So in this case, x is less than 7 over 3. Okay, so that's the first part of my solution. Now I'll move to the other simple inequality that I have. 8 is less than 7x plus 3. I'm going to go ahead and subtract 3 from both sides of this inequality as well. That leaves me with 5 is less than 7x, and then I divide by 7 to get my x by itself, and I'm left with 5/7 is less than x. Now I have not forgotten this is an AND statement, so both solutions have to be true, and I can actually go through the process of combining them again as they were when we started. And so if I want to do that, my x is my common denominator, if you will, not denominator, but my common variable here. And so I'm going to be very careful with my signs here. And so it's going to be 5/7 is less than x, which is less than 7 over 3. And so this would be my final solution for this compound inequality. Now I'm also going to go ahead and show that solution on a number line, which is pretty commonly used with inequalities and really a pretty useful visual tool. In this compound inequality, I need to make sure the values I'm looking at are both contained, and so I'm going to have a mark for 5/7, and I'm going to have a mark for 7 over 3. Now with compound inequalities and number lines, you're going to have dots over the values that are expressed, and you're going to have arrows or lines that go and represent the solution in certain directions. Now in this particular number line, it says that 5/7 is less than x. Okay, the first thing I'm going to decide, I'm going to use an open circle over 5/7, and the reason I'm using an open circle is because x cannot actually equal 5/7, but it's greater than 5/7, so this is going to go this direction, my arrow, if you will. Then I also have to take into account the 7/3. Well, x can also not be 7/3. It's less than 7/3, so I'm going to use an open circle there as well. And my arrow, since x is less than 7, the numbers are less to the left. And what happens is these arrows run into each other, and so this is my solution on a number line that represents the same thing as I have written here. It basically says x can be anything between 5/7 and 7/3. Now I mentioned at the start that there are two types of inequalities that are compound. The first one is an AND statement like this. The second one is an OR statement like this. The good news is solving them is essentially exactly the same. In this case, they're already broken down into two simple inequalities. So starting on the left, I subtract 1 from both sides. That leaves me with 2x is less than 9. Okay, and then from this point, I'm going to go ahead and divide by 2. And x is less than 9 over 2. Now, this in this case is an OR statement. I'm going to keep that in mind. And then I'm going to go ahead and look at the next part here. 3x minus 9 is greater than 12. I'm going to add 9 to both sides. That leaves me with 3x is greater than 12 plus 9 is going to be 21. Divide both sides by 3. And x is greater than, x is greater than 7. Now this is an OR statement. OR statements work a little bit differently in that only one of them has to be true for that to be a solution. So x is either less than 9 over 2 or x is greater than 7. And so when we go to look at our number line situation for this one, we have to keep that in mind, okay? I'm going to have a point for 9 over 2 and a point for 7. Now looking at my number line, starting with the 9 over 2, it's an open circle, and it says that x is less than 9 over 2, so my arrow is going to go to the left. Okay, and then looking at 7, it says x is greater than 7, so again I'm going to use an open circle because x cannot be 7, but it can be anything greater than 7. And so this would be my number line solution, and this would be my solution for my OR statement compound inequality.